finish dynamic simulation, and you might want to save this as a new file name so that if you mess something up you can come back to the original. So I'm going to do file save as, and I'm going to call this one, I'm going to call it new cam valve. I'll delete the original cam, and then I'll place the new cam. Now I had you create this in place, and I will insert the new cam into the assembly, and I'll drag it up around here. I'll drag this down a little bit, and then I'll go back to dynamic simulation, and I'll go, and so I have my prismatic on the valve. I have a new revolution joint on this new cam, and I want to set that where this was straight up and down. So I'm going to go to the properties of that revolution joint, and right now I can see that it's about 180. I'm going to put it on 180 so that I know that it's straight up and down. I hit the tab key to enter that. Then I'm going to right click here, and I'm going to set that offset, so now this will become the 0 position. Now I can't just type in 0, because if I typed in 0 it would flip this around to 0 being down. So I'll do set offset, and I may want to flip that Z axis. So let's go back to, where did we do that before? Oh, we'll edit that. So I'll say OK to that, and so I'm going to right click and I'll edit this, and I'll flip the Z axis. Now I might need to check that position again, so let's go back to the revolution. I'll go to properties. Okay, make sure that that's on 0. Alright, now before we had a 2D contact between here and here. 2D contacts or 3D contacts, no contact joints are transferred into FEA analysis. So we need to find a joint that we can use in place of the 2D contact. And it's what I made this surface cylinder for, is that cylinder would follow this face. So I'm going to do insert joint, and I'll do a sliding cylinder on curve, a sliding cylinder curve, and it asks me to select the curve and then select the cylinder. So I need to select the curve first, and then I'll select the cylinder, and I'll say OK to that. Notice it put it up against that automatically, and so it's going to hold it. Even if we didn't have the spring in there, it would hold that against that curve. I want to check my spring force, make sure that that's still the 100 newtons per millimeter, and we'll say OK to that. And we'll open up the output grapher, and I want to show the acceleration curve for the prismatic joint, and so I'll play this again. So I forgot to put my driving force on the revolution joint, so I'll go to the revolution joint, I'll go to the properties, and I'll put in the constant velocity, 360 degrees per second. We're going to run for 1 second, so that will be 1 revolution. Now notice at the beginning of this that there's some noise in here, but that noise we'll see is really insignificant compared to the signal. If we increase the number of points on this, if we increase the number of calculations, we could smooth out that noise. And we can't even see the noise anymore. Okay, so there is our new acceleration curve. I want to import the original curve to superimpose that over this one. So I'll go to open, I'll get the original cam valve data, and then I'll have a folder down here now with the original cam data. I'll drill down in that folder, I'll find the acceleration curve for the prismatic, and I see it superimposed. So in this case red, your curves might be a different color, was my original cam, and blue is my new cam. And notice the sharp transition points on the original cam versus the smoother transition points on the new cam. One of your curves may be upside down, and so if you needed to flip a curve, we could right click on here and go to curve properties and tell it do an active multiplier. I'll do it incorrect just to show, so I'll do -1. So I'll multiply -1 times it. That will flip the curve, and so we see it's going in the wrong direction. So that's not what I want. So I'll edit that curve again and put it back the way I had mine. So yours might need to be flipped. Mine was okay when I set it up originally. So let's turn off that multiplier. I'm then going to turn off these acceleration curves, and we can either do that one at a time, or we can come up here and tell it to clear the screen. And I want to turn on the driving force of both of these. So I'm going to go to the original cam on the revolution joint, and I see here is driving force. I'm going to turn on the driving force for the original cam, the revolution of the original cam, and then I'll come down here and I'll find on the revolution the driving force of the, well, actually this was the original, and then this one was our new cam. So we can see the curves of those two. And if I want to see these names out here better, I can drag these out here so we can see the names of our curves. But this one was the original cam, and this one is the new cam. I then want to create a new curve based off of these two curves, and so I'll select a new curve, and I'm going to call this torque diff for difference. And for my equation, I will select the original. I'll come down here and I'll find the original driving force, and I'm going to then subtract from that. So I'll do minus, and I'll get the new driving force. Okay, if it turns black, it's a valid equation, and also it tells us here that the equation is valid. Now, why am I not able to say it? Oh, so it's saying that I already created a variable with that name. So let's call this torque diff 2. Now let me save this. Right, I'm going to turn off the visibility of the driving forces, and we see the difference. It's the subtraction of one driving force from the other. I will then create a new curve, and I'm going to call this one power diff 2, as I already had done this once, so it would give us that we'd already used that name. And then I'm going to replace this with the curve that we just made, and so here is torque diff 2. I'm trying to replace that. Let me delete this and just, it doesn't let me replace that. Let's see if I can do plus, and then I'll select this torque diff 2. Alright, so I got that in there. Now I'll get rid of this. I'm not sure why it wouldn't let me just replace it. I might not have hit it. You got to hit right on this check mark, and then I'm going to do that divided by 1000. And actually I meant to put up here in parentheses the units, so I'll do parentheses in watt. Okay, so we're going to measure the power difference in watts, and then we have to change the units, so I'll do that times the velocity of the first one. Actually we'll do it of the V1. Actually I got the velocity of the prismatic. That's not what I want, so I need to do that times the velocity of the revolution joint. And we did both of them at the same velocity, 360 degrees per second. And then I'll do that times pi divided by 180. And read the instructions or the explanation of why we did this conversion in here, the dividing by 1,000. The original was in Newton millimeters, where power for watts is given in Newton meters. All right, I'm going to turn off the visibility of the torque diff, and so now we have the visibility of the power diff. Now I did something wrong, and I'm not sure what, but just record the results that you have, and then I want to export this at certain time steps where there are various peaks in here. So I'm going to double click inside the graph and I get this line here, so I'm going to put a time step there, and I have some others here that I had earlier, so I'm going to uncheck any earlier time steps that I had. It might be difficult to find them, and then I'll come over here and I'll just get a couple positions here, and you can use the arrow keys on your keyboard to go through this as well. So I'll click inside here, use the arrow keys, and I'll get that position. So I'll get several positions, and actually you might get it where it's like here, 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 and here, something like that. Anyways, I have some time steps selected. I'll tell it to export to FEA. It'll ask me to select the part I want to check. I want to check this valve. And then it says, where is the prismatic force being applied against this part? And so the prismatic is the up and down is against that cylinder, that shaft, and then the sliding cylinder curve is against this hemisphere up here. And I'll say okay to that, and we'll finish dynamic simulation, and then I'll go to environments, and I'll go to stress analysis, and then I want to create a new study, and I will tell it, instead of doing a simple static analysis, we'll do a motion loads analysis. And so run your analysis at each one of your individual time steps. Now if you did a bunch of the analysis and saw how this part bent, you would see that it actually goes, the top of this actually goes around in a small circle around like that. It bends over slightly, which is what causes this to wallow out this hole, enlarge this hole at the top of it. You give it about a bell mouth shape to that hole, and eventually after 100,000 or 200,000 miles you'll start leaking oil past the valve stem.